Welcome back to Learn Extra. I'm Liesl LaRue, and as I said, I'm going to be helping you guys with questions from paper 1. Now, one lady that had problems with paper 1 was Diana. Hello, Diana. How are you?
I'm fine, thanks. Yourself?
Not too bad. Diana, where are you calling us from this morning?
From Tando.
From?
Tando.
Oh, okay. Now, tell me, this question was in the GDE prelim paper, right?
Yes, it was.
Okay, so let's just quickly make sure it's sequences and series that I've got the question down right. It says 1, 2, 3, all the way up to 2000, right?
Yes.
And calculate the sum of the terms remaining when all the powers of 2 are removed from the sequence. Have I got it right?
Yes, you do.
Okay, now Diana, there's one big trick to this question. What I'm going to do is I'm going to do, firstly, sum formula on the sequence just like it's given here, okay?
Okay.
Then I'm going to write down all of the powers of 2 as a sequence, right? And I'm going to subtract that. So that's the key thing, is that we're going to have to subtract. But let's start at the beginning. What sort of a sequence do you think this one is, arithmetic or geometric?
Arithmetic.
Arithmetic, definitely. And we want the sum to 2,000 terms. You agree with me?
Yes. Yes.
Okay. So now I'm adding in the 2's, the powers of 2. That's not a problem. I'm going to take them out later. That's the only way that you can do this one. So I'm going to write Sn is equal to n over 2, 2a plus n minus 1d. Right? So straight off the information sheet. And then I'm going to say 2,000 over 2 gives me 1,000.
Yes.
Twice the first term, okay? So the first term is 1. Now there's going to be 2,000 terms, right? So that's going to be plus...
2,000 minus 1.
Yes, that's right, 1,999 times the common difference, which is?
1.
1. Okay. So let's calculate that first, and then we'll have a look at the rest.
Okay.
Okay, so let me just clear my calculator, and that's 1,000. Okay. Bracket 2 plus 1,999. I could probably have done this in my head, eh? But it is Saturday. It is Saturday morning, so we'll forgive ourselves.
Okay.
So it's 2,001 000. Okay, have I got it right? Yeah.
Yeah.
2,001
000, yes.
2,001 000. Okay, and I expected it to be quite big because there's 2,000 terms, so that's all good. All right, yes. Now Diana, and this, whenever they talk to you in a paper, and it might happen at the end of the year, about removing things from a sequence, remember this tip. Work out the sequence without removal, and then make a separate little sequence for the things that have to be removed, and then subtract the one from the other. Okay, so you'll remember that. Okay, so now this is a lovely question. I love it. I've done it before. The powers of 2. So what are the powers of 2? The first one will be 2, and the next one will be 2 squared, which is 4, and 2 cubed, which is 8, and so on.
Okay.
Okay. So my sequence is going to go 2, 4, 8, 16, 32.
16,
okay.
So on.
Okay, so this is geometric, right?
Yes.
So we're going to work with the sum of a geometric series, but there's one other thing that we need to just watch out for. If I write down my formula, I suddenly realize that I don't have n. So I need to work out how many powers of 2 are there that are lower than 2,000. Do you see what I'm saying? So you need to work out how many terms are there in this sequence. So you'll just take your calculator and you can test a couple of things. 2, let's try 2 to the power 8. 2 to the power 8 is 256. Okay, let's times it by 2. That gives me 512, so that's 2 to the power 9. 2 to the power 10 is 1,024, okay? But 2 to the power 11 is already over 2,000. It's 2,048. So my last term in this sequence will be 2 to the power 2 to the power 10. Let me just double check that I've 2 to the power 10. Yeah. So that's 1,024. So that's how I know what my value for n needs to be. So I'm going to say 2 times, my common ratio is 2, okay? My n is 10 minus 1 over 2 minus 1. Are you following so far? Are you happy?
Yes, I am.
Okay, so now I've got 2 to the power 10. I'm going to subtract 1 from it. And I'm going to multiply it by 2. So I'm just calculating here quickly. And this gives me 2,046. So now the actual question, remember, asked me, what is the sum of the sequence once the powers of 2 have been removed? Now, the sum of the powers of 2 is 2,046. So to calculate what the sum is once the powers of 2 have been removed, I'm going to say 2 001 000 minus 2046.
Oh, okay.
Okay, and that gives us our final answer. But listen, this is a tricky question. Did you write the GDE prelim?
No, I didn't.
No, you didn't.
No, I wrote the Limpopo prelim paper.
Okay, but it's really a very, very good idea that you're doing it as practice. And how are you finding most of the questions so far, Diana? Difficult, not so bad?
No, the rest of them are actually very easy.
Really? So you have obviously mastered the syllabus quite nicely.
Yes,
Have you been working hard throughout the year?
Yeah, very.
Okay. All right. Now, Diana, it's been an absolute pleasure chatting to you. And if you come across more things that bother you, please feel free to phone us again.
Okay, I will do.
Okay, guys.
Thank you.
Thanks, Diana. That was Diana with a lovely question on sequences and series. And on that note, what I'm going to do is I'm going to do the sequences and series questions from the KZN paper. So let's just have a look quickly. Let me pick a nice one. Right. So let's have a look at the first question. We might as well start with the first question. Question 4. They said, how many terms in the series 3, 8, 13 must be added to give us a sum of 2,265? Now, guys, whenever we're dealing with a sequences and series question, our first order of business is to establish what sort of sequence we're dealing with. Now, 3 plus 5 gives me 8. And 8 plus 5 gives me 13. So immediately I can say that I'm dealing with an arithmetic. Now, they say how many terms must be added to give a sum of 2265. So that means I'm dealing with the sum of an arithmetic. And I'm going to write down the sum formula. Right. Now, somehow I often find that people use 2265 as the n. Guys, don't. That is the answer for the sum. We want to know how many terms do I have to keep on adding until eventually I get to 2265. So how would we deal with this one? We're going to say 2265 is equal to n, which is our unknown that we're trying to solve for, over 2. 2 times a, which is 3, that's our first term, plus, again, n minus 1 multiplied by the common difference, and the common difference is 5. So I would say that this question is really a bit of a giveaway. We don't even have to understand too much about sequences and series itself. We just need to be able to substitute it in and solve the equation. So definitely the question that Diana phoned through was quite a bit tougher. Right, now what I'm going to do is I'm first going to deal with the inside of the bracket. So I'm going to say 2 times 3 gives me 6. Then 5 times n gives me 5n, and 5 times negative 1 gives me minus 5. And my 2265 over here again. And n over 2, 5n plus 1, simplifying the inside of the bracket, and 2265. Now, many people will be a little bit freaked out by that 2 in the denominator. So what I'm going to do is I'm just going to multiply through by 2. So I'm going to say 2265 multiplied by 2, and that is 4,530 equal to, now this just becomes n. So n times 5n gives me 5n squared, and n times 1 gives me 5. Now, it's important to bear in mind that with sequences and series, if we are solving for n is like a place in the race. You can come first, you can come second, you can come third, but you can't come 4 1/2. So we're looking for an integer and a positive integer value. Okay, I'm going to divide this equation through by 5, so it becomes n squared plus n, and 4,530 divided by 5 is 906. Okay, now guys, I'm not exactly an expert with the factors of 906, and you could be in for a bit of a long haul if you're going to do trial and error the whole time. So rather than waste the time, I'm going to start off by just using the quadratic formula. So I'm going to say x is equal to minus b plus or minus the square root of b squared minus 4ac, everything divided by 2a. Right, so my b term is 1, so it's minus 1 plus or minus 1 squared minus 4 times 1 times negative 906. And all of that is divided by 2a, so that is 2. So let me just quickly do a bit of a calculation here. We're going to say 906 multiplied by 4, add the 1, and let's see what the square root is. Sorry, 906 times 4 plus 1. So the inside of my square root sign is plus or minus root 3625, everything over 2. So let's see what the square root of 3625 is. Holding thumbs. And actually, guys, quite interestingly enough, I do not get a whole answer. So what I'm going to do is I'm just going to go back and I'm just going to check my calculation and make sure that I didn't perhaps make a mistake. Otherwise, it could be just that I need to round up. So 2265 is equal to n over 2. 2 times my first term, and my first term is 3. N minus 1, and d is my common difference. So far, so good. I get 6, 5n and negative 5, that's all correct, which simplifies to 5n plus 1. Right, so I haven't made a mistake yet. Now, I'm going to, oh, and I found my mistake. Guys, you see it happens so easily to the best of us. N times 1 is just n, not 5n. So there we go. So what I'm actually dealing with, sorry about that, but that just goes to show you that we can all make mistakes. But it's very important that when you look at your answer, you interpret it and you say, oops, no, that doesn't look quite right to me. Let me go and check. Okay, so I'm going to erase the rest of my question, and I'm going to go back to this point over here. That is 5n squared plus n, not 5n. So I'm going to say, right, 5 n squared plus n minus 4530 equal to 0. And once again, guys, big numbers, not necessarily too easy to solve. You might get lucky if you play around on your calculator and get the correct answer immediately. But let's not waste any time, and we'll put it straight into the quadratic formula. X is equal to minus b, which is minus 1, plus or minus the square root of b squared, so that's 1 squared minus 4a, which is 5, and c, which is negative 4,530. everything divided by 2a. So that's going to be 10. Now what I'm going to do is I'm just going to calculate the inside of my square root first. Okay, I'm going to start. Let me just move it across so that I can see. I'm going to just work out the inside of the square root. So I'm going to say 4,530 multiplied by 20 equals plus 1 equals. So the inside of my square root is 90601. Right, and then I'm going to calculate the square root, and I'm going to hope that this time I get an answer that makes more sense. And once again, I don't. So 90601. Oh, there we go. The square root of 90601, what a relief, 301. So I'm going to say my answer is minus 1 plus 301. I feel very relieved now. Divided by 10, and that is going to give me an answer of 30. And then negative 1 minus 301 divided by 10. Now this is going to give me a negative answer, so I can already discount that. Remember guys, n is like a place in a race. You can come first, second, third. So that means that going back to the top of the question, of this series 3, 8, 16, I must add a total of 30 terms together before I get to 2265. And the first time I did it, guys, my part under the square root worked out to be a decimal. And I was very suspicious that I must have made a mistake. So the trick is to go back, check your answer, and hope for success in the end. Right, guys, if you've got questions for us, the number to dial is 0861 058 262. Also, you can email us helpdesk@learnextra.co.za. We're going to take a short break. Right after the break, I'll be back with our next caller.